Imagine asking an AI for a simple photo of a rainy Tokyo street. In seconds, it hands you this stunning, cinematic masterpiece.
Right. I mean, it looks completely flawless at first glance.
But then you look closer. The customer on the corner is holding two umbrellas. One of those umbrellas is somehow melting into a bowl of ramen.
Yeah, and the neon street signs are just, alien gibberish.
It really is a beautiful illusion. Welcome to the Deep Dive. I'm so glad you are joining us today.
We are tearing down that illusion today. We have a pretty serious mission here.
We absolutely do, because honestly, I still wrestle with prompt drift myself. Like, fixing just one word often breaks the entire image.
It drives everyone crazy, and that is exactly why we're here. We are putting 3 top-tier models through an absolute gauntlet.
We have GPT Image 2, Nano Banana 2, and Grok Image 2.
Right. We are running them through 5 brutal real-world tests to see which one is actually worth paying for.
Let us jump into the first scenario. We are testing complex prompt following. The scene we requested is a rainy Tokyo ramen stall at night.
That classic cyberpunk aesthetic. Models usually eat that up.
They do, but we loaded the prompt with heavy conflicting constraints. We asked for exactly 5 people.
And the vendor had to wear a red apron, hold a white towel, and carry a ladle.
Plus, we wanted a customer in a yellow raincoat. They need a clear umbrella with a blue handle. And crucially, they must have absolutely no phone in their hand.
Oh, that negative prompt is a trap. Telling a machine what not to draw is notoriously difficult.
Wait, I want to unpack that. If I explicitly type the words no phone, isn't the model just deleting phones from its process?
Well, no, because of tokenization. When you type the word phone, you are introducing that mathematical token into the model's latent space. It is like me telling you, do not think about a pink elephant.
Right, and suddenly I am picturing one.
Exactly. The concept is now active in the math. The model has to work incredibly hard to suppress the visual representation of that token.
That explains so much. To finish the prompt, we also asked for a specific bowl order on the counter: red, white, and black.
With steam only allowed from the white one.
Right, and a red bicycle on the far left with its wheel turned.
That is just a massive cognitive load, so how did they handle the pressure?
GPT Image 2 took the win for this test. It scored a 9.5 out of 10.
Wow.
It nailed almost everything, exactly 5 people, and the bowl order was perfect.
It kept that rainy cinematic mood intact too, right? Without hallucinating random objects.
Yeah, it did really well. Nano Banana 2 struggled more, scoring a 6.5. The realism looked great, but it failed the strict counts entirely.
It added extra people into the street, and it gave the yellow raincoat customer a second umbrella.
Grok Image 2 was the fastest to generate, but it scored a 5.5. It completely failed the negative prompt.
Let me guess the customer was holding a phone.
Right in their hand. It also broke the spatial rules. The background people were supposed to be under a striped awning.
But Grok just scattered them into the rain.
Trying to render this prompt is like balancing a checkbook, where the math keeps changing on its own. You fix one variable, and 3 others shift.
The attention mechanism in the model just gets spread too thin. It loses track of the rules.
Is speed worth it if the model completely ignores the negative instructions?
No, ignoring constraints just creates more editing work later. Beat.
So, if GPT Image 2 can perfectly parse physical objects like raincoats and bowls, how does it handle human language? Language is abstract.
This is a fascinating leap. Text is notoriously difficult for AI. They do not understand phonetic letters.
They just see complex geometric shapes.
Exactly.
We tested them with a graphic design poster, a fictional Tokyo event called Midnight Market.
The constraints here were incredibly strict layout rules.
We demanded a dark black background, red, cream, and silver accents. Strict typography rules, like Midnight Market in the top left.
And the date needed to sit inside a red box in the top right.
We also explicitly forbade fake Japanese characters. No random symbols allowed.
Right in the center, we asked for a chrome sphere reflecting light, and exactly 3 thin red geometric lines behind it.
GPT Image 2 took the win again with a 9.5. The text was beautifully clean, and the layout was spot on.
What was its only flaw?
The red lines, they looked a bit more like thick geometric shapes rather than thin lines, but a very minor deviation.
Nano Banana 2 scored an 8.5. The text readability was actually great.
Yeah, but it failed on constraint discipline. It added extra red lines that we never asked for.
And the sparkle.
Right. It threw in this completely unprompted aesthetic sparkle near the text.
Grok Image 2 scored an 8.7. Surprisingly clean text, but it added a massive red bar on the left side.
Totally unprompted. Why do these models still invent extra graphics when told not to?
They overcompensate, trying to fill empty space with aesthetic noise. Beat.
We're going to take a quick pause here. Sponsor. Welcome back. So text on a poster is essentially flat. It is a two-dimensional layout.
But the real world has depth. Do these models actually understand space, or are they just faking it?
That brings us to our third test, spatial reasoning.
Which is such a huge hurdle for these systems.
Let us define that briefly. Spatial reasoning means understanding how objects physically relate to each other in 3D space.
It tests logic. Left, right, behind, under, above.
We gave them a modern reading room to build. A desk in the center, a red chair on the left, a blue chair on the right.
The trickiest element was the backpack.
Oh, absolutely. We asked for a green backpack on the floor. It had to sit exactly between the red chair and the desk.
Completely outside the footprint of the desk itself.
We also added a white cat. It needed to sit under the desk, but specifically facing the blue chair.
Plus framed pictures aligned above specific items. GPT Image 2 won this round with a 9.4.
It is remarkably reliable for these spatial puzzles. The chairs were correct. The backpack was in the right zone.
This cat was positioned beautifully. Did it miss any relational logic at all?
Just one small alignment issue. A square picture on the wall wasn't perfectly centered over the blue chair.
But the overall comprehension is staggering. Nano Banana 2 scored an 8.6.
It handled the backpack well, but the cat was facing the entirely wrong direction.
Grok Image 2 really fell apart here. It scored an 8.1.
Yeah, Grok shoved the green backpack completely under the desk.
Yeah.
And the cat was facing the front left, ignoring the blue chair entirely.
So what is actually happening under the hood here? Why is left and right so hard for a supercomputer?
Because the AI does not have a 3D engine. When a video game renders a room, it creates a mathematical z-axis.
It plots coordinates in 3 dimensions, but the AI doesn't do that.
No, the AI predicts flat pixels. It knows that pixels representing a cat and pixels representing a desk often overlap in its training data.
So it just groups those concepts together based on statistical probability.
Yes, it does not truly understand the semantic meaning of under. It just mimics the visual patterns associated with the word.
Does struggling with left and right mean the model lacks true comprehension?
Yeah, they predict pixels. They don't actually build a 3D mental map. 2-sec silence.
Let us shift away from pure logic. Understanding where a chair goes is one thing.
But making the wood grain and the leather look absolutely real is an entirely different beast.
Test 4 focuses purely on aesthetics. We are testing photorealism.
We asked the models for a portrait of a 35-year-old female ceramic artist at golden hour.
And we demanded raw realism. We explicitly asked for visible pores, freckles, and absolutely no beauty filters.
Hands are always the ultimate AI test. We needed 5 perfect fingers, unpainted nails, and traces of wet clay on the skin.
We also demanded distinct material textures: linen on the apron, cotton for the shirt, wet clay, and dry wood.
Plus 3 distinct bowls on a shelf behind her.
Grok Image 2 finally took a decisive win here. It scored a 9.5.
The textures were unbelievable. Captured the most natural camera feel.
The way the clay dust hung in the air caught the golden hour light perfectly.
Whoa, imagine conjuring an editorial-grade, hyper-textured portrait from your living room in seconds.
It is truly mind-bending. Grok did miss one logical rule, though. The bowl was resting on the bench instead of fully in her hands.
But the raw realism was so breathtaking it won the category. GPT Image 2 scored a 9.2. It followed the rules much better, but it had a totally different vibe.
It looked way too perfect. It looked like a heavily produced million-dollar advertising campaign.
Nano Banana 2 got an 8.7. It rendered very believable skin.
But it moved the balls from the shelf to the window, and it added another unprompted watermark and sparkle.
I want to talk about GPT's hyper-polished look. Why does it default to that advertising sheen?
It comes down to human reinforcement. These models are trained on internet data, which is heavily photoshopped.
But then they go through reinforcement learning from human feedback.
Exactly. Human testers tell the AI what looks good. And human testers consistently rate bright, smooth, idealized images higher than gritty, imperfect ones.
So the AI learns to default to perfection? Is GPT's tendency to overpolish actually a flaw for professional photography?
Absolutely. Perfection destroys the gritty authenticity needed for true photorealism.
Beat. We have tested logic, text, spatial awareness, and realism individually.
What happens when we force a model to juggle all of those elements at the exact same time?
That is the final gauntlet. Test 5 is multi-constraint design.
We essentially asked the models to act as a full-service ad agency. We created a brief for a fictional sparkling water called No VA.
This brief was an absolute nightmare. We asked for a deep midnight blue background and 3 slim cans.
We gave exact color codes: matte silver, glossy blue, and matte white.
The word no VA had to be written vertically down each can. We needed exactly 4 ice cubes, and none of them could sit in front of the center can.
We asked for a thin, curved splash of water, exactly 5 surface water droplets.
And specific typography. A headline reading "Case Denied," and a white call to action box saying, "Try Novia."
Trying to render this prompt is like stacking Lego blocks of data while someone bumps the table.
That is exactly how the attention matrix feels. Nano Banana 2 actually won this round. It scored a 9.3 out of 10.
Nano Banana was the dark horse.
It really was. It held the complex brief together beautifully. It kept the water splash perfectly situated behind the cans.
And it managed all the typography without cluttering the layout.
GPT Image 2 scored an 8.8. It really lost control of the water mechanics.
It rendered a massive, chaotic splash that drowned the cans, and way too many water droplets.
The subtle elements just collapsed. Grok Image 2 scored a 7.9.
Grok completely dropped the Try No VA call to action. The button just vanished. It also missed the surface droplets entirely.
Why does a powerful model just forget a huge element like a CTA button?
It is context dilution. Every constraint you add forces the model to divide its attention weights.
When you demand 5 droplets, 3 colors, and 4 ice cubes, the mathematical weight assigned to the text gets crushed.
It literally runs out of focus.
When a model forgets the core CTA button, is the image essentially useless for marketers?
Yes, a gorgeous ad that forgets to sell is just expensive wallpaper. Beat.
So we have run the gauntlet. Let us tally the final standings and figure out what this actually means for you.
GPT Image 2 takes the overall crown. It finished with a 9.28 average. It won 3 out of the 5 tests outright.
It is definitely the safest choice for strict detail. If you need precise text, perfect counts, and spatial obedience, GPT is your primary tool.
It obeys logic better than the rest. But Nano Banana 2 surprised me. It finished with an 8.32 average.
It is the absolute dark horse for heavy design briefs.
When you need a multi-constraint layout, it balances all those competing elements wonderfully.
And Grok Image 2 finishes with a 7.94 average. Grok struggles deeply with strict rules and negative prompts.
But if you want the undisputed king of raw, unpolished editorial photorealism, Grok is untouchable.
You know, seeing these scores really drives home a crucial point. Do not just look at generic top 10 lists online.
You have to pick your tool based on the specific battle you are fighting today.
Exactly. Are you fighting for perfect typography on a poster? Or are you fighting for the gritty realism of human skin texture?
The right model changes entirely based on that answer.
I highly encourage you to test this phenomenon yourself.
Yeah.
Take one single, highly detailed prompt from your own work. Run it through 2 different models today.
You will clearly see these hidden biases and architectural flaws emerge in real time.
It really is the best way to understand how these diffusion systems actually process information.
Absolutely.
Which brings up a lingering, somewhat philosophical question to leave you with. We have seen that these models still struggle with basic object permanence, like failing to understand that a cat is facing left instead of right. So how long until they finally realize they are not just painting static pixels on a flat canvas, but mathematically simulating our entire 3D reality?